Hello and welcome to my SPR600 Project Phase 2 video report. My name is UnrealIRCd and today I'll be going over the UnrealIRCd exploit that was found on the Metasploitable 3 Ubuntu machine, and I'll be talking a little bit about how one can use the Metasploit tool on Kali in order to exploit it. Furthermore, I'll be showing you the kinds of artifacts that you can find on a network capture file using software such as Wireshark in order to perform analysis and to later on develop a Suricata rule in order to detect this kind of attack. Further on, in order to test this rule, I'll be performing a live attack using exploit and viewing the alert triggered by Suricata on Security Onion and such, demonstrating that the rule works. So with that, let's get started. So the way I discovered this attack, I performed an OpenVAS scan on the victim domain and the victim network. And as such, I was looking for any kind of particular high vulnerability for the Metasploitable 3 Ubuntu machine, which had the IP address of 10.25.0.5. So when I was looking through all the specific vulnerabilities that were detected, I came across this one right here, the UnrealIRCd authentication spoofing vulnerability, which had a severity of 8.1, which is pretty high. So I decided that I wanted to go for that specific vulnerability. As we can see here, it's targeting port 6697, which is the port that UnrealIRCd uses. For those who are not familiar with UnrealIRCd, it's a IRCd daemon, which means it's a software that runs in the background, and as such, it's used to relay communication and traffic, between text chats and weblogs and things such as that. As we can see here, it's particularly vulnerable to a backdoor vulnerability. It's as such, we can see here, the flaw exists within the authentication function of the msfconsole.c script, and as such, the vulnerable software is for versions 3.2.8.1, and it got patched later in 3.2.10.7. And we can also see here that this particular exploit allows the remote attacker to spoof a certificate fingerprint, and such they can log in as a regular user, and as such they can perform remote code execution. From what we can see here, the particular CV is identified by this, so if you can also put this for further reference for your Suricata rules. So now I'm going to be showing you how do I actually perform this kind of attack, and by setting up the payload. So we're going to go into the Metasploit tool on Kali using msfconsole. So we're going to search for UnrealIRCd, find any exploits for it, and we find one. We're going to copy this, and we're going to use it. Paste. There you go. So now we're going to show our options, and we're going to see which fields that need to be filled out in order to perform this attack. So we need both our hosts, our port, although not specified here. We also need lhost, which is our local host, and also the payload that we're going to be running when we execute this attack. So first we're going to specify our host to be 10.25.0.5, which is our Metasploitable 3 Ubuntu machine. We're going to set our own IP address, the local host, to be 10.25.0.4, which is our Kali's IP address. We are going to also specify our port to be 10.25, or so not IP address. It's going to be 6697, which is the port that UnrealIRCd is using on the Metasploitable's end. Finally, we're going to set the payload to be command Unix, and we're going to do reverse curl for this particular one. I've seen many other demonstrations where they've used multiple different kinds of command Unix payloads, such as reverse Ruby. Although in their demonstrations worked, in our cases it did not actually generate a session for us to actually perform backdoor activity on, so we're going to use reverse curl instead. So before I actually exploit and run the attack, we're going to quickly go over through a previous Wireshark capture of the attack what kind of things you're going to be looking for in your Wireshark. So as we can see here, initially the attacker is trying to communicate with the UnrealIRCd server, but once we go through, we can see that the server or the attacker is trying to upload the payload. So we can actually flip the stream and see what it's actually doing. So the payload itself can be visible here. As we can see, we have the unique identifiers of AB semicolon Perl, which identifies that it's this kind of Perl payload. And as it's trying to search for any kind of key certificates on the environment, and copy them and then send them over to the peer address, which is 10.25.0.4, which was our attacker's IP address on port 4444. So this helps you identify who's actually sending this kind of payload and what IP address they're coming from or what port they're connecting through. And as such, once the actual attack has been launched and it's been successful through the exploit, the UnrealIRCd server will respond back with AB semicolon Perl you have not registered, which is basically it's saying that you've authenticated, but the host name, which for some reason it comes out as AB semicolon Perl, is not registered. So this is what you will be looking for once the actual attack has been successful. Particularly when we want to be looking for the hex values for the AB semicolon Perl string. So when we click here, for example, we would be looking for 41, 42, 3B, 70, 65, 72, 6C, which would encompass all of that entire string and hex value. We can also further along see in the packet traffic that once they've actually authenticated, they can perform any kind of command they want as a user. For example, when I was running this particular attack, I ran the command who am I, and the server replied with Boba Fett. So now that this is what we would see in a particular attack, we're gonna use these knowledge. We're gonna use this knowledge and apply it to our Suricata rule. So I made two particular ones. I made one to detect the actual payload being run on the UnrealIRCd server. So in order to do this, I set the alert to be TCP, so it's looking for TCP traffic. You can use home net if you want, or external net if you want for the network specification, but I just did any for the source IP address and port. And I did any for the destination, and I specified 6697 for the destination port, because that's specifying that's trying to communicate with the UnrealIRCd server. I set the message to be this exploit using Perl payload. I set the contents to be the hex files that we mentioned earlier that are the unique identifiers for the specific payload. And I specified this class type to be string detect, which basically means that the alert will say that, oh, we detected a suspicious set of strings that match the content that you specified earlier in your rule. And for reference, we're putting the CVE that we mentioned before in the open bus, and we have given it a unique signature ID. Now the second rule will detect whether or not the server actually responded back with a successful authentication saying that you are not registered. So instead, it's basically the same thing as the previous one, but instead we're switching the source port to be 6697 and making so the destination port to be any. That being said, this is what we'll be using in order to detect the actual attack. I've already gone ahead and updated my rules so that it will be on my security end, so that it will be already there in order to detect when I launch this attack, and we can prove it here. D. They've been appended at the bottom, so they're already being loaded and ready to go. So now all we have left to do is actually perform the attack. So I'm going to get this ready. As we can see, last 15 minutes, nothing has happened. We're going to go on to Kali and run the exploit. So here's where we can see, you can see in our previous traffic that it's trying to looking up our host name, but it couldn't, and is using IP address instead. Here where it sent the backer, which we saw before with the Perl. And at this point, this is when the command shell has been opened, and this is where it would say that you are not registered. And we can see here, we have a shell, and we can say who am I, ID, etc. So now that the attack has been performed, we're going to see it on the security onion. And as we can see here, it's been launched. We can see Unreal exploit using Perl payload has been detected through the alert section of security onion. So now we're going to go on to the Kibana and see if it got uploaded here as well. Perfect. It got uploaded, and we got that alert triggered. You can see that this is the alert that has been raised. This is the source IP address that instigated this alert. So therefore, it caught our Kali machine IP address. This is our destination port, which is showing who is the victim. In our case, it was the msfconsole 3 Ubuntu machine, and the destination port 6697, which proves that it was trying to exploit the UnrealIRCd server. We can also look into the category, as we specified before, suspicious string was detected, the rule ID that was triggered, which we specified before, and we can look further into the data here. We can even see the specific packet that it found for right here, the AP Perl MO, which is the payload that was ran, and the rule right here that we've used to detect this attack. So that was it. Thank you so much for watching. I hope this was informative and allowed you to create your own rule, and feel free to use the rule I made and tweak it a bit in order to fine tune it to detect other types of Unreal IRCd exploits using the different kinds of payloads. That being said, thank you so much for watching and have a great day.